So pause the question and have a little read at the question before we go over it, so that you're involved in the question. Okay, so looking at the question, let's just sort of break it down and do a little bit of thinking about the question. We've got compound I is a complex. Okay, so when you see the word complex, you're thinking about transition metal ions, right? And you're thinking about ligands. All right, but notice it doesn't say a complex ion, right? It says that it's a compound, and you know the compounds are neutral. Compounds have to be neutrally charged. Okay, so we've got the empirical formula, and the thing about empirical formulas are that they don't give you any clues as to the structure. They just list out the atoms in their numbers. Okay, so moving on to the second paragraph here, we've got the formula of compound I. Again, it uses the word compound again, so you're thinking neutral charge. Contains one chloride ion. Now, we're very familiar with chloride ions. We know that they have a 1- charge. So the complex ion, notice now they're calling it a complex ion, all right, and that's J, all right. So this here is I, all right, and that's the whole compound. But the complex ion J is I, not including the chloride ion, all right, not including the chloride ion. So that means it must have a 1+ charge. Yeah, because if the compound is neutral and the chloride ion is 1-, then the complex ion J must have a 1+ charge. All right, and by the way, it's got 2 stereoisomers. So let's just have a little revision about stereoisomers. So stereoisomers. So stereoisomers are either geometric or optical, all right, and this is when you've got mirror images. That's when you've got mirror images, and geometric is EZ or cis-trans. Now this question is all about transition metal ion complexes, so we're talking about cis-trans in this case, and we've got monodentate ligands, right? I'll go back to how I know why we've got monodentate ligands, but we've got monodentate ligands. So when you've got 4 of one and 2 of the other, then that's going to give you cis-trans isomers. So let's just put monodentate, and when the 2 odd ones are at 180 degrees to each other, that's when you've got trans, and when they're at 90 degrees to each other in an octahedral shape, that's when you've got cis. Okay, so we've got that little bit of revision of stereoisomers going on in the back of our heads. So let's just think now a little bit more about this complex and how I was able to say that it's monodentate ligands. So let's write out the formula of the complex ion. So we've got cobalt, and then we've got N4H12Cl2. Now Cl2, not Cl3, because the chloride ion is the anion of the compound, and we've got the cation of the compound, which is a +1. Okay, so now these have to be chloride ions, right? So these two are 2 chloride 1- ions. So that leaves us with this part of the ion here, and so you're just going to need to notice that that is 4 times ammonia molecules. 4 times ammonia molecules, and so there are 6 ligands. We've got 4 ammonia molecules and 2 chloride ions in an octahedral shape around, why octahedral? Because we've got 6 ligands in an octahedral shape around a cobalt ion. All right, and while we're here on the cobalt ion, this cobalt ion must be a 3+ ion. All right, because if the whole ion is 1+ and we've got two 1- chloride ions, then the cobalt itself must be a 3+ ion. All right, so before we actually get onto, right, so I'm going to just draw a little bit of space here. I'm going to draw the two ions in that space on the right there, but on the left here, just want to do the dot structure of ammonia for you, because a couple of you, well, in fact, quite a few of you struggled with this. All right, so let's do the dot structure. All right, of ammonia. Right, so our central atom is nitrogen, and we know nitrogen is in group 5, so we've got 5 outer electrons. Right, we're going to make the nitrogen electrons dots. Okay, so we're going to draw a dot like so for one of our nitrogen electrons. There's the second nitrogen electron, there's the third nitrogen electron, because we know it's got 3 bonds to 3 hydrogens. All right, so here's our 3 hydrogens. Right, and we'll do the hydrogen electrons as crosses, like so. But we've only drawn 3 dots so far, and we know that nitrogen has 5 outer electrons because it's in group 5, right? So the other 2 electrons exist together as a lone pair like that, which makes this ammonia molecule a good nucleophile. It's a nucleophile. I won't write that out, that's a bit near the edge. So this is this lone pair, right, is going to make a coordinate bond with our cobalt 3+ ion, and so we've accounted for nitrogen's 5 electrons there. Okay, so hopefully that helps some misunderstanding in an ammonia molecule and how it bonds to our cobalt central ion. All right, so let's do what we've been asked to do and draw our 3-dimensional structures. Okay, so let's start off and draw our trans. Okay, so what I would recommend is that you start off with your basic structure of an octahedral shape. Okay, so we're going to have 2 ligands coming out of the screen. All right, so we draw them as wedges. 2 ligands going into the screen, so we're going to draw those as hashed lines, and then ligands above and below in the plane of the screen there. Okay, so that's our basic octahedral shape, and if we want to draw trans, then that means two of the ligand that we only have 2 of is going to be, they're going to be 180 degrees apart. So the ligand that we have only 2 of are chlorides. All right, so we're going to put a chloride there. All right, and we're going to put a chloride there because that's 180 degrees apart from each other, which leaves our 4 ligands being ammonias. Right, so we're going to draw the N on the end of the bond, right, and our rest of our ammonia molecule like so. So notice I've drawn those in reverse direction because we need to say that it's the nitrogen that's making a coordinate bond with our cobalt central ion. All right, and the last thing to do then is just to put our square brackets around it, and the whole ion there is going to have a 1+ charge. Just to reiterate that, we've got a 3+ cobalt central ion, but 2 of those plus charges are neutralized by our 2 chloride ions, so we've got a resultant just 1+ ion there, and that would then make an ionic bond with the 3rd chloride in the empirical formula. Okay, so I'm running out of space, so I'll just change color before we draw the cis stereoisomer. Again, we're going to just draw our cobalt with our basic octahedral shape in the same way, like so. But this time we want the bond angle between our ligand that we only have 2 of 90 degrees. So let's just pick these two here. These two are at 90 degrees, right? So we can put a chloride on there and a chloride on there, which means the rest are going to be ammonias, like so. There you have it. So there, and this, just to be complete, I'll label this as our cis isomer. So, and last thing, let's just put our charge on there. We put it in square brackets because the charge is over the whole ion. You know, it's the net result of the cobalt and the chlorides. And okay, so there you have that question answered, and hopefully that's cleared up any misconceptions. Thank you.